Okay, while I'm gone today, you guys are going to take a few notes. You're going to take notes on polygons. This is page 13. So, before you get started, I'd like you guys to try a warm-up here. I want you to graph two things. One, see if you can graph x is less than 4. And two, graph x is greater than 2. Now you should pause the video, and then you should try graphing this. Okay, so my first one here, 0 is there, and 4 is there. 2, 3, 4. Now this in English is saying x's are less than 4. So I'm going to be at 4 here, and I'm going to show everything less than 4 by shading to the left. Everything over here is less. I'm not going to fill in this circle. I'm going to leave it open because this is strictly less than 4. You can't be equal to it. Okay, and so on the other side here, I have 0, and I have 1, 2, 3, 4. I'm going to put a circle around 2. I'm actually going to fill it in 2 because this is equal to. And then it says x is greater than or equal to 2. So I shade in the right side here. Now we could add another question here. We could say, let's combine these. Let's say x is less than 4. We're going to intersect that with x is greater than or equal to 2. So we have to be able to graph just that part. Now I can do this because these are on a computer, but I'm going to take this. I'm just going to line it up underneath what we had before. Now you might notice, you might see that this is where they intersect. So in your notes, you could put a 0 here, and they start to intersect back here at 2, and they end intersecting over at 4. That's where they're crossing over. So we have a filled in 2, we have an open 4, and we're just going to shade only where they overlap. So if you were to see a problem like this, you just have to think, where are they crossing over if we line them up like that? Okay, so that was a quick review from yesterday. Now let's talk about polygons. So we first will talk about triangles because that's the simplest type of polygon. Triangles, we're going to just do a draft. We're going to do a rough draft of a definition. So I'll write draft here. Some people might just do the definition as a union of line segments. And I should have put 3 in there, 3 line segments. Okay, so let's just say that that's how we define a triangle. Now we're going to show that this is not complete. This is not completely accurate. For example, these are triangles that fit our description here. I have 1, 2, 3 line segments. And they're unions, they're put together, but you'll notice that that isn't a triangle. I could even do this. Or this. So we have to be a little bit more complete with our definition. And so here is the revised, here is the true definition. It gets a little technical. The union of points P1 to P2 line segment, union P2 to P3 line segment, union P3 to P1 line segment is a triangle if and only if, remember that IFF means if and only if, each segment only intersects at their endpoints and are not collinear. So what that means, here's a picture. Here's P1, here's P2, And I couldn't put like a P3 right here because that would be on the same line. So I need to put a P3 out here. P1 line segment P2 is just this, P2 to P3 is just this, and then P3 to P1 is just that right there. Now notice they're only intersecting at their endpoints, and they are, I should have said in the definition, not collinear. And that's our triangle definition. So we're being very specific to make sure we don't end up with weird things that still fit the definition. So the other thing that we need to talk about is naming. We're going to have polygons with 5, 6, 7, 8, 9, 10 sides. So here is my polygon. Now this guy has 5 sides, so it is a pentagon. A, B, C, D, E. Now we're going to name this guy, and naming is really easy. As long as you start at one point and continue all the way around in the order that they are in the polygon, you're going to be okay. So I could have A, B, C, D, E, and that is the name of this pentagon. Or I could start at point D and then go backwards. I could go D, C, B, A, E. That would be okay. There's actually a ton of ways to name this. I could start with C and go D, E, A, B, and that would still be okay. The only thing that you can't do, these are not good, I cannot go from C to E to D to B to A, because then I would be going C, E, D, B, A, and that is not outlining the order of the polygon. Alright, so we also have to talk about regions in a polygon. There is the interior and there's the exterior. So here we're going to do another pentagon. We'll call this Q, R, S, T, U. So we have the interior and we have the exterior. Now you may remember, we've talked about this a lot, that to tell if a polygon is convex, you should not be able to find 2 points where if you drew a line between them, they would go into the exterior, the line would. So in this case, this is a non-convex pentagon. Now if we drew any 2 points and the line always stayed within that pentagon, that would be convex. And one more thing to say about this, if we have a pentagon, and let's go back to A, B, C, B, E. We have one other thing. It's very simple. It's called a diagonal. If you connect any 2 points within the interior of the figure, that is a diagonal right there. So for example, EB is a diagonal, AC is a diagonal, DB is a diagonal, EC is a diagonal. So there are quite a lot of diagonals. In a square, you only have 1, 2. Okay, and then lastly, there are 3 types of triangles we need to remember. First of all, you might have a triangle with no equal sides. This guy is called scalene. So let me write that, no equal sides. Okay, there's also something called isosceles, and that's when you have 2 sides that are the same measure, but the third does not have to be. And then lastly, if you require that all the sides are equal, this guy is called an equilateral. 3 equal sides. So there's something called inheritance that we need to just note about this. You may notice, hey, if I have an equilateral triangle, it has 2 equal sides, doesn't it? So if it has 2 equal sides, this is also an isosceles triangle, but it goes a step further because it has a 3rd equal side, and so we can also call it an equilateral. An isosceles is not an equilateral because it can only have 2 sides. Isosceles do not have that 3rd side equal. And so there is something called inheritance. So if you start with polygons, there's a special polygon called a triangle. And what we do there is we just require 3 sides. Once you have 3 sides, you have a triangle. Then, if you require that you have 2 equal sides, then you have an isosceles triangle. So you're getting more specific as you go down. And then if you have 3 equal sides, then you have equilateral. Now if you have no equal sides, then it is an isosceles. So as you go down the tree of inheritance, you get more specific. You're adding more requirements on your polygons. And the cool thing is, if you go up, anything lower on the tree will have all the properties of it above. If you are an equilateral triangle, you are also isosceles, you are also a triangle, you're also a polygon. Okay, so here's your assignment. Number 15, page 92, numbers. Please bring 14 and 15 tomorrow, ready to be graded. We're going to do both, and bring any questions that you might have.